Today we will start with a new topic, basic electricity. And after that, we will also discuss electric circuits. In these topics, these are the objectives that we will be looking at. First, we will understand the basic electrical principles, understand the concept of current flow, electrical pressure, resistance, and energy. We will also know the equation for electricity based on the charge and determine the number of electrons present in a given charge. We must remember that the electrons are the particles that are responsible for electricity. So what is really electricity? We know how electric charges behave when staying still. But what about when they move? The collection or flow of electrons in the form of an electric charge is known as electricity or current. So therefore, electricity is simply the flow of electrons. If there is no flowing of electrons, there is no electricity. Now let us try to understand how electricity is produced. Let us use as an analogy the flow of fluids. So let us consider the first figure here. Consider a pump and a pipe and a reservoir. Let us consider that the pipe in here is at this level. Let us consider this one as the level ground. And the position of the other end as somewhat elevated. If you will notice, from this point here up to this point, there is a difference in height. And we know that if there is a difference in height, there is also a potential difference. So therefore, even in the absence of the pump, if we have a pipe where the other end is elevated, the fluid or the water will flow by itself. So what causes the water to flow? The cause is the difference in height. So, or in other words, it is because of the potential difference from point 1 to point 2 which causes the water to flow. And if you will notice, the speed at which the water will flow will also depend on the diameter of the pipe. So how about if the two ends are on level ground? let us say that this one here is not elevated. Let us say that this is completely a horizontal level. There is no potential difference. If there is no potential difference, the water will not flow. So would that mean that we cannot make the water to flow anymore just because there is no potential difference? In the absence of potential difference, we can create another, or we can actually come up with another way by which we can make the water to flow. This time, we need to create a difference in the pressure. So if we are to introduce a pump at this point, the pump in here at this point, we will be introducing a pressure. So at this point here, the pressure is higher than the pressure on the other end. Now it is just natural for fluids to move from a higher pressure to a lower pressure. So therefore, even though the ground is a level ground, since we increase the pressure on this other end, this pressure here, which is caused by the pump, will actually cause the water to flow. So this illustration in here is actually the same principle on how electrons move. Remember that there is only an electricity if the electrons will flow at a specific direction. So by itself, the electrons in an atom, they are just moving. They usually move around the atom, and that does not create an electricity. So therefore, in this case, we also have to create a potential difference. We need to push the electrons. In order for that electron that we push, that will also in effect push the neighboring electrons in the direction of the force. So therefore, if we are to look into this water, the pump creates the pressure. The battery actually is also doing the same as what the pump is actually doing. In this case, instead of a pressure, we are creating a potential difference. So the potential difference in here is not because of a difference in height, but because of a chemical reaction that takes place in the battery. So therefore, the battery in here is actually creating a potential difference. So the potential difference in here is also known as voltage. So in some problems, sometimes you will be asked to determine the potential difference. This is actually, potential difference is the same as the voltage. So you also have to use the equation where there is a voltage, and in that way you can solve for the potential difference. So therefore, the amount of electrons that is flowing in here is proportional to the amount of electricity that is produced. So if we have a lot of electrons that is flowing through here, you could say that the magnitude of the electricity is also higher. So in here, the amount of charge that flows per second is now what we call this the current. Now let us look closely about this potential difference or voltage. Sometimes this one is represented by EMF, meaning electromotive force. Although we are using the word force, the electromotive force is actually not a force. So we are just using this to illustrate that the electromotive force or the potential difference is actually the force behind that causes the electrons to move in one direction. So that's the reason why we are using the word force, even though we are actually not relating or not referring to force per se. So the electromotive force is actually the voltage. Now the voltage is represented by a big V, sometimes delta V, sometimes the Greek letter epsilon. The unit for voltage is joules per coulombs, or simply volts. Now let us look into current. Again, current is defined as the rate at which charge flows through a surface. When we consider the word rate, we are looking at time. So therefore, this one here is the equation for electric current, or simply current. I refers to the current, Q refers to the charge, we know that. The unit is coulombs or C, and T refers to elapsed time, which is in second. So coulombs per second is also known as amperes, or simply amps, or simply A. The current is in the same direction as the flow of a positive charge. Now notice that the flow of the current is starting from the positive going that way. So that is the direction of the flow of electricity. However, if you will notice, this one is the negative terminal. The flow of the electrons is actually in that direction. So even though we say that the electricity is the result of the flowing of the electrons, the direction by which the current is flowing is not the same direction taken by the flowing electrons. If you still remember that from the positive charge, it is at this positive terminal where the electric field line originates. In the same manner that the electric energy is also originating from the positive terminal. So please remember that the direction of the flow of the electrons is not the same direction taken by the electricity, even though electricity is the result of the flow of electrons. Please remember that. Let us review again the equation for current. The equation for current is given by this. where I is current, and please notice that the SI unit is coulombs per second, or simply C per second. Remember that coulombs per second is equal to amperes. The Q is the charge, which is in coulombs. The T is the time, which is in second. If we know the charge, it is also very easy for us to determine the number of electrons that is present. So in effect, this here is the equation that you will use if you will be asked to solve for the number of electrons. You simply divide the charge, which is given, by the charge per electron. Now what is this quantity? Now we know that one electron has a charge of negative 1.6 times 10 to the negative 19 coulombs. So therefore, if you know the charge, you just divide it by 1.6 times 10 to the negative 19 per electrons. You will cancel out the columns in the columns, you will get the number of electrons. Electricity could be classified into two types. First, we have DC, or direct current. This is the type of electricity that is generated if you use a battery. And another thing that you have to remember about DC is that the electricity flows in one direction, and it is constant for a given period of time. DC is the type of electricity that is proper when you are operating small equipments that needs only a small amount of electrical energy to operate, like a calculator, a flashlight, small electronic devices. So this can be operated using a DC. The other type is the alternating current, or AC. The main difference, if you are to compare AC from DC, is that the manner by which the electricity moves. In AC, the current reverses direction many times per second, meaning AC devices turns off and on. An example is a wall outlet. Now, since the AC can be turned off and on, the amount of electricity that is flowing for a particular period of time is not constant. It actually fluctuates, as represented by this graph. We use AC to operate equipment that needs a large amount of electrical energy. Another thing that you have to remember is that in order for electricity to flow, these three conditions should be satisfied. The, the first one is the source of energy. In this example, it is the battery. And then it should be a closed path. So we are actually referring in here to a circuit. And then there should be a device which uses the energy, let us say a lamp or anything that uses electricity. Sometimes we call that load. And this actually offers a certain amount of resistance. Now the resistance also can be offered by the size of the wire that is used. So what this one is telling us is that if the circuit is open, the device will not work, meaning there is no electricity that will be flowing. To best illustrate this, let us try to draw a diagram. Let us say we have this diagram. Let us say that this one is the load, and then we connect that here, and let us say that this one here is a switch. We usually in a diagram of a circuit, if you see something that looks like this one refers to the switch. So if this switch is open, the circuit is considered to be an open one. Hence, if it is open, the electricity would not be able to flow. So the device in here will not work because there is no electrical energy that will make this to move to work. So what do we do then if we want to make this one operate? And by the way, this one here is an example. We call this one here as an open circuit. The switch is off. So if you want to turn this on, you just close the switch. Then we will have a closed path, and then again there will be electricity that will flow. Now let us try to solve some problems and apply what we learned. So let us analyze the problem. How long does it take a current of 5 milliamperes to deliver 15 coulombs of charge? Notice that the unit for current, SI, is amperes, not milliamperes. So this one here is a prefix and we need to get rid of this. Before we could use the given in the problem. We are given also the charge, which is 15 coulombs. So let us solve the problem using the guess method. So we are given the current, and current is represented by I. So we have in here 5 milliamperes. Milli is simply 10 to the negative 3. So therefore, to get rid of the milli, we change the milli to 10 to the negative 3. So this should be written as 5 times 10 to the negative 3. This time we now have the proper unit in amperes. The other given is the charge. So we know the charge is represented by Q, and it is 15 coulombs. Now this time, if you notice, the unit of the charge is already the SI unit, so you don't have to do anything. So what are we looking for? It says how long. So therefore, we are actually looking for the time. So the equation, by definition, current is the charge per unit time. So what you do, just what we've been doing before, if it is a 3-variable equation, it is always safe to fill that in the triangle. So at the top, we fill the Q. On the left side, the I. On the right side, the T. So if we are looking for T, we are looking for this, we divide Q by I. That would be the T. Okay, let us continue. So therefore, from our equation, a T is Q divided by I. So we have 15 divided by 5 times 10 to the negative 3. So if you are dealing with exponential numbers, you just divide the base. So 15 divided by 5, that will give us 3. And then take this up, change the sign to positive. So therefore, this would become 3 times 10 to the third. What is the unit of time? It is in second. So therefore, our time is 3 times 10 to the third second. Next problem. If there is a current of 10 amps in a circuit for 10 minutes, what quantity of electric charge flows in through the circuit? So let us use the guess method again. So we are given the current. So current again is represented by I, and we have 10 amps. We already have the proper SI unit, so we don't have to change anything. And then we're also given 10 minutes, and we know that minutes is a unit of time, so we have 10 minutes. Now notice that minutes is not the SI unit for time. So we have to change this to the proper SI unit, which is in second. So we apply our dimensional analysis, multiply this by our conversion factor. In 1 minute, we have 60 seconds. So we cancel this out. The time would be 600. So what are we looking for? We are looking for the charts. What is the symbol for charts? The charts is Q. So what would be the equation? By definition, go back to the original equation. I is Q over T. And you can again use your triangle and fit the variables inside. So you have Q, I, and T. So since we are looking for Q, notice we are looking for this, and I and T are side by side, so meaning you have to multiply that. So therefore, the equation for Q would be simply I multiplied by T. Okay, so let's continue. So Q is equal to I multiplied by T. So plug in the values. I is 10 and T is 600. So therefore our Q would be 6,000 columns. Now let us try to determine the number of electrons flowing. So to solve for the number of electrons flowing, we just divide the charge by the charge of one electron. So we know that the charge of one electron is 1.6 times 10 to the negative 19 per, that is coulombs, per electron. So if we plug in the values, we have 6,000 divided, and this one is in columns, divided by 1.6 times 10 to the negative 19 coulombs per electron. So what do you notice? This cancels out, and solving this, the electrons would be, the number of electrons would be equal to 6,000 divided by 1.6 to the negative 19. The answer is 3.75 times 10 to the 22nd electrons. So this is the number of electrons that is actually flowing for that given charge if we have 10 amps electricity. Next problem. How much current must there be in a circuit if 100 coulombs flow past a point in the circuit in 4 seconds? So again, let's start with the guess method. We are looking for the current, so that is our unknown. And we are given coulombs. So what is coulombs? Coulombs is the unit of charge, so therefore Q is given 100 coulombs. The unit is already the proper SI unit, so you don't have to change it. And the other one that is given is 4 seconds. Seconds is the unit of time. So we have 4. So what is the equation? By definition, current is charge divided by time. Do we have to change the equation? Not anymore. So we just plug in the values. So I is equals to Q over T. Q is 100 and T is 4. So this one would be 25 coulombs per second. Or simply, since coulomb per second is the same as ampere, so therefore the current is actually 25 amps. This is our answer. Okay, next problem. If there is a current of 2 amps through a hair dryer transferring 15 kilojoules of energy in 55 seconds, what is the potential difference across the dryer? What is the charge of the hair dryer? So let us write down the given. We are given the current, and that is our I, which is 2 amps. We are also given the energy. So our energy is, let us just consider that as E, which is 15 kilojoules. Now notice that the unit of energy in SI is simply joules, not kilojoules. Kilo means 1,000. So to change this, we just add 3 zeros. So that would be our energy. So we're also given 55 seconds, and we know that second is the unit of time. So therefore, we have 5 seconds. Now what are we looking for? We are looking for the potential difference. Now remember, potential difference is the same as the voltage, so we are simply looking for V. And then we're also looking for the charge, so we have Q. For this given problem, if you will notice, based on the given, we have I and T, so therefore it's a lot easier for us to solve for Q first. So what are the equations? The equations that we can use is first, I is equals to Q divided by T, and for the voltage, we know that the voltage is given by this equation. We know the energy, the potential electric energy is equal to Q multiplied by the voltage. So therefore it is safe to solve for Q first in order for us to be able to solve for the voltage. So let us do just that. So solving for Q, from this equation, Q divided by T, so Q would be I multiplied by T. So plug in the values. Our I is 2, our T is 55, so our Q would be 110 coulombs. Now since we know the charge, we can now solve for V. To solve for V, remember that the equation is energy is equals to Q multiplied by V So we can also fit this in a triangle. So E on the top, Q on the left, V on the right. So if we are solving for V, V would be equal to E divided by Q. And we know that E is 15,000 joules divided by our Q, which is 110 coulombs. So we have the V is 136.36 joules per coulombs, or simply volts.